Closure line of aortic valve on a mode echocardiogram is seen as central line, while in bicuspid aortic valve it is an eccentric closure nearer to one of the walls of the aorta. This eccentricity of closure of the aortic wall leaflets can be calculated using what is known as eccentricity index. That's an important feature of bicuspid aortic valve on M-mode echocardiogram. This is an M-mode echocardiogram at the aorta-left atrium level. You can see the cursor on the 2D echo, and this is the closure line. This is normal aortic valve. Central closure as a single line. During systole, one opening motion is seen towards the anterior aortic wall and another motion is seen towards the posterior aortic wall. It forms almost like a box or rhomboid shape. That is the normal aortic wall opening seen on echocardiogram, and the closure sign is central. Closure line is central. You can see distance from both aortic walls are almost same. This is due to a ectopic beat. We can see that the beat has occurred early, and the opening time is also less. Opening excursion is also less, and there is a pause. This is because the previous diastole is short, so that cardiac output, or rather stroke volume, during this particular beat is lesser. That is why lesser opening and shorter duration also. So this is a premature beat. So this is an M-mode echocardiogram of the aorta and left atrium in a case of bicuspid aortic valve. This is the left atrium and this is the aorta. It's a closure line. You can see that the closure line is eccentric, not midway between the anterior and posterior walls of the aorta. Opening motion is good because there is a good systolic opening here. And the eccentricity index of aortic valve closure is calculated by dividing half of the aortic diameter on a mode, that is A by 2, is divided by the distance from the aortic cusp, that is the systolic region, to the nearest aortic valve. It is taken as the nearest aortic valve. So half of A divided by B will be taken as eccentricity index. So if it is central closure, both will be equal. So it will be 1 or maximum up to 1.25 is the normal range. 1 to 1.25 is the normal range for the eccentricity index. But in case of bicuspid aortic valve, it may be something around 2.5, and it may vary up to even 5 in very eccentric cases. So that is known as eccentricity index. It was important in the diagnosis of bicuspid aortic valve, mainly in the era of M-mode echocardiography, when two-dimensional echocardiography was not freely available. Still, it's an important measurement which we often see during M-mode echocardiogram. Eccentricity index of the bicuspid aortic valve is calculated based on the closure line position in diastole. This is just for familiarity to show the difference between the open position of the bicuspid aortic valve and tri-leaflet aortic valve. This is parasternal short axis view. In normal valve, you can hardly see the leaflets because they are open and almost approximate to the aortic wall. So you will be hardly able to see in real systole. Systole is identified here by the pulmonary arterial color flow mapping. And this is the corresponding or echocardiogram in bicuspid aortic valve. You can see two leaflets. So you can understand that bicuspid aortic valve is intrinsically somewhat stenotic because the leaflets are not actually touching the aortic walls, and then this is likely to be regurgitant also, because bicuspid leaflets are likely to have both stenosis and regurgitation, and both can progress as age advances, so that they may present with aortic stenosis most often in the older age group.